Hello, welcome to another video of thermodynamics. In this video, I'm going to explain how the approximate analysis of ideal gases and exact analysis of ideal gases is used to find the entropy change of a process uh, in an ideal gas system. Now, the first, uh, we're going to look at the approximate analysis. That's called the that's also called the constant specific heat analysis. First of all, let's look at the two equations that we talked about to find the entropy change of ideal gases. The first equation is S2 minus S1 equal to integral 1 to 2 Cv of T dt over T plus R natural log of V2 over V1. The second of them is S2 minus S1 equal to 1 to 2 integral Cp T dt over T minus R natural log of P2 over P1. And these three equations, S is entropy, Cv is constant, a specific heat of constant volume, R is the gas constant, ideal gas constant, V is specific volume. Here again, Cp is specific heat of constant pressure. R is the ideal gas constant, and P is pressure. T is in both equations refers to temperature in Kelvin scale. Now, when we goes to approximate analysis or we can say that constant specific heat analysis, in these two cases we can assume Cp and Cv are constants. Cp and Cv are constant. So for the equation 1 and equation 2, for 1, if Cv is a constant, S2 minus S1, we can directly take Cv out of the integral, Cv integral 1 to 2 dt over T plus R natural log of V2 over V1. From here, I can take Cv. This can be written as natural log of T2 over T1 plus R natural log of V2 over V1, S2 minus S1. From equation 2, from equation 2, we can obtain that S2 minus S1, now Cp is a constant, take it out of the integral 1 to 2 dt over T minus R natural log of P2 over P1. Now by integrating the first integral, Cp natural log of T2 over T1 minus R natural log of P2 over P1. Now, if you are asked to use, or if you want to use the constant specific heat analysis, you can use Cp or Cv at the room temperature, or you can use the average temperature during the process. If you say that initial temperature is T1, final temperature is T2, you take T1 plus T2 over 2, and then find that temperature and find that Cp value using your textbook, and then you can find the constant value for Cp and Cv both and use in these two equations. So those are the two equations. Change of entropy S2 minus S1 equals Cv natural log of T2 over T1 plus R natural log of V2 over V1. And then also S2 minus S1 equal to Cp natural log of T2 over T1 minus R natural log of P2 over P1. So those are the two equations that you can use in approximate analysis or constant specific heat analysis. Okay. Now, I would like to move into the next type of analysis, which is called the exact analysis. In the exact analysis, let's say that's exact analysis. Now, in the exact analysis also, we're going to depend on the same two equations that we obtained earlier, that is S2 minus S1 equals C integral Cv integral 1 to 2 Cvt dt over T plus R natural log of V2 over V1, and then S2 minus S1 equals 1 to 2 Cpt dt over T minus R natural log of P2 over P1. Now, what we're going to do is, the problem is that we don't have this integral, right? Now, in this analysis, actually, we don't take this equation. We don't take this equation because all the tables are, but we're going to refer back to tables in this case, are made for this equation. So we're going to use only the second equation. So what they have done is that they integrate this term, the first term of the left hand side of the second equation, okay, equation 2, the first term, this is called second term. Let's take only the first term, which is denoted as S naught. This term is denoted S naught 1 to 2 Cp T dt over T, right, which is denoted as S naught for any temperature, right? Let's say that's S for any temperature from 0 temperature, wherever Cp is 0, to any temperature T, this has been integrated. So if you wanted to find 1 to 2 Cp T dt over T, right, it's going to be S2 naught minus S1 naught. Now, by substituting this equation 2, we can write S2 minus S1 is equal to S2 naught minus S1 naught, right, minus R natural log of P2 over P1. Now, what is this S1 naught and S2 naught? These are tabulated for you. Any textbook, you can find these values for any type of ideal gas, S1 naught and S2 naught. When you know the temperature, you can find S1 naught and S2 naught, temperature of the gas. Then you know the pressures, then you can find the entropy change. So these are tabulated. These are tabulated. For the purpose of, if you take a standard textbooks of thermodynamics like Sengel and Bowles, they have in table A17. So it goes to table A17, and then you can find these values from table A17, and then you should be able to find the entropy difference in that process in the exact analysis. For exact analysis, you always need to look into the tables, and from the tables, if you know the temperature, you can find the values of S2 node and S1 node. Thank you very much for watching. See you in another video.